All right, thanks for joining us. In this video, we're going to look at a few additional practice problems on using the law of sines and law of cosines and being able to identify which to use. We're not necessarily going to work through every one of these problems, but we will look at setting up the various problems so that you can understand the approaches. All right, so here we're going to be using our calculator, and notice that we're going to be asked to give our item to the nearest hundred, which is 2 decimal places. Okay, so we want to solve each triangle, and anytime you're asked to solve a triangle, one of the best things you can do initially is to sketch out your triangle and the information that you have. All right, so if I say angle ABC, I know that in here I have 112 degrees for angle C. Opposite, I have 5, and opposite A, I have 7. Okay, so if we look at this situation that we have drawn out, we have this situation of a side, an angle. Therefore, I might be ambiguous, right? And in this case, right, we would have no triangle possible. And the reason we have no triangle possible is because obtuse angle must be opposite the longest side. And we'll notice this obtuse angle of 112 degrees is opposite a side length of 5, and that side length of 5 is less than 7. So no triangle is possible here. All right. If we look at another situation that we might have side angle, that's going to be over here for number 3 if we look based on what's provided. And once again, the easiest thing to do is go ahead, A, B, C, and label what you have. So we have angle B is 36 degrees, side opposite is 8, and opposite the A is 10. And so we notice that there is a side angle, right? You can also think of it as angle, side. And in that situation, we could have ambiguity, right? So we could have what we call our ambiguous case. So how do we set this up? We can start by saying, I know that the sine of 36 degrees all over 8 must be equal to the sine of A all over 10. All right? So that means that the sine of A must be equal to 10 sine 36 degrees all over 8. And if I make that computation, I want to make sure that my calculator is in degrees. So I'll come and ensure that my calculator is in degrees. Then I'll come to my calculations. So I have 10 times the sine of 36 degrees, all divided by 8. That's the sine ratio. And then I'm going to do the inverse sine of that value. And so that gives me that my first triangle would be the measure of A is about 47.3 degrees. All right. The measure of B is 36 degrees, and the measure of angle C we know is going to be adding up to 180 degrees. So 180 minus 47.3 minus 36, and that is 96.7 degrees. Okay. Now, that's one triangle. I have to consider the fact that this 36-degree angle is a small angle and it has a shorter side than the 10. So I have to consider the fact that angle A could also be obtuse. So that's going to be 180 minus 47.3. So I could have angle A be 132.7 degrees. Right? Angle B we know is 36 degrees. and that would change angle C. We'll do 180 minus 132.7 minus 36, and that's going to be 11.3 degrees. Now, it tells us that we need to go to the nearest hundredth, and so we notice that, hey, we're only given this to 1 decimal, so we actually have to go back and give things to 2 decimals, which means this 47.3 would actually need to be 47.28. 180 minus 47.28 minus 36 is 96.72, and so that affects this angle to be 96.72 degrees. And similarly, if we do 180 minus 47.28, because we were asked to do 2 decimal places, that would be 132.72 degrees. And this would change 180 minus 132.72 minus 36. This give me 11.28 degrees. So those are the angle measures. But I also need to find the side lengths. So obviously we know that we have one side length here regardless, right, that or have a side length A equals 10 in both of these situations. Side length A equals 10. We have side length B equals 8. Side length B equals 8 in both situations. But our side length of C is going to depend on the angle that we have with C. So I know that the side length of C all over the sine of 96.72 degrees must be equal to the side length of 8 all over the sine of 36 degrees. And so if I have 8 times the sine of 96.72 all divided by the sine of 36, that gives me 13.52. So side C would be 13.52 in length. And I'll call that C1. So that's C1. And C2, I know the ratio of C2 to the sine of 11.28 degrees must be equal to 8 over the sine of 36 degrees, once again using that law of sines or the sine rule. So we've got 8 sine 11.28 divided by the sine of 36, and that gives me 2.66. So the other possibility is that I had a side length of 2.66. So this situation, right, we call the ambiguous case. All right. And if we look at number 2, we're not going to work number 2, but let's just show a setup, and we'll say A, B, C. So angle B is 30 degrees, angle C is 45 degrees, and side B is 9. So that gives me angle, angle, sine, and I could use the law of sines to solve. All right. And if I continue here, I'm given 3 sides, right, that I have. Across from A is 6, across from B is 10, and across from C is 7. I know that this is going to be my law of cosines, and then followed with my law of sines. Right? So it's going to be the associated work. The associated work, using the law of cosines, I want to find my biggest angle first. So I'm going to know that 10 squared is going to be equal to 7 squared plus 6 squared minus 2 times 7 times 6 times the cosine of that angle B. So solving, I've got 10 squared minus 7 squared minus 6 squared. All right, take that number and divide by negative 2 times 7 times 6. Take the inverse cosine of that value, and that gives me that angle B is 100.29 degrees approximately to 2 decimal places. All right, then I can use the law of sines to find my other angle, right? Because I can say that the sine of 100.29 degrees all over, right? If I wanted to, the sine of 100.29 degrees all over 10 must be equal to the sine of A all over 6. Or I could say that 6 squared must be equal to 7 squared plus 10 squared minus 2 times 7 times 10 times the cosine of angle A. So it doesn't matter which one I use, right? I'll be able to figure out my angle. So I'll go ahead and do the cosines. And we'll have 6 squared minus 7 squared minus 10 squared. Take that number and divide by negative 2 times 7 times 10. All right. Find the inverse cosine of that value, and that gives us 36.18 degrees. And the angles must add up to be 180. So 180 minus 100.29 minus 36.18. That gives us 43.53. All right. If we look at this last triangle, to get this set up, I have, it looks to be EDF, where side E is 9, side D is 5, and angle F is 115 degrees. So this is a side angle side situation. For side angle side, I know I'm going to use the law of cosines. And with the law of cosines, I would have the following, right? With the law of cosines, I'm going to need to find the length F, right? And I'm going to need to find my other angles. So let's go ahead and do that work. All right. What do we have here? We've got that unknown side is going to be E squared is going to be 5 squared plus 9 squared minus 2 times 5 times 9 times the cosine of 115 degrees. So 5 squared plus 9 squared minus 2 times 5 times 9 times the cosine of 115 degrees. I know it's very dry, but you need to make sure you can do the work well. So it gives us 144 approximately. Right? If I take the square root of that value, that gives me 12.00. All right, so it's not exactly 12, but very close to 12, so I have the length of 12.00. So now I need to find another angle, and I know that the sine of E all over 9 must be equal to the sine of 115 degrees all over that 12.00, but I'm going to be using my answer that I have. So I'm going to have 9 sine 115 degrees divided by that 12.00 that I got. That's going to be my sine ratio. Take the inverse sine of that value, and that's going to give me my angle. And so that means the angle E is 42.82 degrees. And the only thing that I'm left to find is angle D. We know the angles in the triangles sum to be 180. So 180 minus 42.82 minus 115, and that gives us 22.18 degrees. So a bit of work. You got to be careful with the work, and want to make sure you understand how to do the work. Okay. If you pause the video, go ahead and go back and see if you can solve the triangle over here for number 2, and we'll post the solutions for it after you pause the video. Okay. So the first thing you should probably do for number 2 is to get that third angle of 105 degrees. And you can do that by using your angles in a Euclidean triangle summing to be 180 degrees. All right, pause the video and see if you can find the other side lengths. Okay, so the side length A, if I use the law of sines, I set up my ratio that A to the sine of A is going to be equal to B compared to the sine of B, right? The ratios are in proportion. So I set that up and I get 17.39 approximately as a side length. And how would you find that last side length for side length C? Pause the video and see what you get. Okay, so for side C, you would set up the law of sines once again. All right, use your calculator. So 9 times the sine of 45 divided by sine of 30, and we get that side C is approximately equal to 12.73 as our side length. So once again, be careful with your work. All right, if you have side-side angle, you have an ambiguous case, but it might be that you don't have a triangle possible. Right, consider the side lengths and the angle sizes, right? Biggest angle, longest side. If I have angle side, that's going to be law of sines. Once again, side to side angle or angle side side, that's going to be our ambiguous case, in which case it might be that you have two triangles possible. Right? If you have all three sides given, then you're going to use the law of cosines to find the first angle. Then you could use the law of sines or the law of cosines to find the other angles. And lastly, if you have side angle side, you can use the law of cosines to determine the other side lengths and use the law of sines with it as well to determine the last angle measure if you need. All right. So make sure you practice, make sure you ask questions for clarification, make sure your notes are nicely written. All right. Good luck to you.